got another video for class 14 in ES110. This is, I affectionately refer to these as door handle problems. It's a little bit more complicated. The first challenge that we have is to try to draw this in 3 different views, and that can be very challenging. So what we want to try to be is kind of systematic about it. I think the most obvious one from the way this is displayed to look at first is the XY plane. Sometimes that's not the case, but it's a little bit easier, I think, if you for that direction for this one right now, right? So creepy eye is looking in that direction onto this thing. So what we want to do is maybe we just want to follow, write out first FBD and define our direction, and then just follow this thing and follow the path, right? It goes upwards, right? So we know we're going to go upwards, and then it goes to the right, in the positive X direction. So there you go. And then it starts to go in the Z direction, but we can't see that, right? Looking back down here, we see a certain amount up on here. So this is 28 minus 16, so this actually goes 12 upwards right here. We have a part that comes to the side. And so that's what it looks like. So it's nice to make these look like the thing. And I'm putting a circle there because this is coming at us, right? And I could have done a little bit better of a job drawing this thing. I don't know what's wrong with me today. I'm not really in the best drawing mood, I guess. All right. So now we apply the forces and we take a look. We can see that there's these 200, 150. So the 200 is coming downwards, and the 150 is coming this way. It might be easier to draw it like that way instead of putting the arrow head. Instead of putting the arrow over here, we put the arrow over here, right? So that we can show it so it doesn't like overlap. And then we take the 350 pounds. We also want to draw the reactions. Well, we could tell that the reaction here at this place where we're cutting it, right? We're doing it about the section that contains H and K. It's going to have a reaction that's coming upwards right here, because this is the only one that's vertical, the other one in the Y direction. So this is going to be the reaction RY. And I'm not going to bother giving it a letter. It says H and K. Maybe we could just call it H and forget that K is even there. And then we also want to take a look and see what the X direction is going to be. And this is going to 150 this way, 350 this way. So it's a net of like 200 that way. So the reaction is actually coming that way, right? So here's our RX. And if we didn't know, we just pick the positive direction. Now here's one where we don't necessarily know the direction. Is that true? No, actually we can actually figure out, because both of this is going clockwise and this is going clockwise. So the reaction is definitely counterclockwise, and I'm going to call it MZ because it's going about the Z axis. And maybe I'll put a little R in there. Maybe that's my new trend is when there's a reaction moment. I'm going to put an R in there so that we don't get confused when we write out the sum of the moments. And we're taking it about the Z direction is equal to 0. So we don't think that this right here, which is generally about Z, isn't the same as this. This is a specific value. This is the reaction moment, right? And it never occurred to me until like recently that could be confusing for some students. So maybe I'm going to try to mitigate that confusion. By the way, it looks like there's something next to that R, and there's nothing next to that R. I think I just tapped it on with my pencil. And look at the smudges I make. It's not good drafting. All right. So walking through this, we see that I often will just put the reaction on there, MZR, right? That's counterclockwise, and it's on there, so it's a moment we have to consider. Now we got 350. That appears to be also counterclockwise, and I didn't put the dimensions on there. That's 12, and this is 16 to there, and then this is 20 across. Boom, boom, right there. Okay, nice to have those dimensions on there. I think it's like usually a kind of an appropriate thing to do. So that's going to go times 12, that 350, And then we also are going to have this 200. Now it's going to be, that's 200, negative 200, because it's clockwise times 20. So negative 200, and the moment arm is 20. And then we have 150, that's also negative, and its moment arm is going to be that 16 plus 12, or actually we're given over here is 28. It's really critical that you get the direction and which is moment arm is appropriate for the thing. And if we do that, we have MZR, the reaction moment, is going to be 4,000 inch-pounds. And counterclockwise, right? Sure. All right, now we got to do a little bit more work here. Let's do another FBD. Here, and we're sliding it back and forth to take a look. Let's go ahead, and I decided to go in the XZ direction, right? So what is that? That's going to be creepy eye looking downwards onto the thing. All right, so there's X and Z, so we're looking in that plane. So what we're going to see is this thing, and then it's going to come down in the Z direction, right? So let's put this on here. It's going to be X and Z. And we're going to do it's going to have long, 20 inches long this way, right here. So I'll just draw it as a line to start with. Then it's going to go in the Z direction right here, the positive Z direction, down. And there's going to be like a, this is where we're going to look, we're looking down at this piece right here. So I'm going to draw that as a circle right here. And then we're also coming off to the side by 12 inches. So I'm now going to draw all those in. Right, and now I'll put the loads on here. Well, there's going to be 150 right here, because that's right here, 150 pounds. And you're not going to see the 200 because that's coming down into the page right here in the Y direction. And then we have the 350 that's being placed on there, so 350 pounds. And we might as well put some dimensions onto this. This dimension right here is the 16 inches. 16 inches. These dimensions aren't going to matter because this is the 20 inches right here, and then this is 12. But if we take the sum of the moments, and we're going to take it about the y-axis, declare what positive is, and oh, we didn't put the reactions. So the reactions, it's tough to write this one in here. It's going to be ugly. I'm going to write it this way right here because it's kind of inside the thing. And that's going to be the RX direction. And there's nothing happening in the Y, so we could even just like write, the Z, we could put in the RZ. In fact, it kind of makes more sense to make it positive, doesn't it? Even though it's going to be equal to 0 because there's no forces in the Z direction. So coming back to this, oh yeah, I forgot. I got to put a reaction moment in there. There's got to be something that's stopping this thing from spinning, and it's the reaction inside this thing. So this one's going counterclockwise. So this one, and I made a bad choice of where the arrow goes right here. I like to label these near the arrowhead right there. So there you go. I didn't want to make a spin here, so let me go M, Y, and let's say call it the reaction right there. So that's a negative MRY reaction, so I'm writing here as a negative, and then it's going to be plus 150 because it's counterclockwise times our 16. And this guy passes through the point, so he doesn't have a moment arm, so it doesn't create a moment on this. And so we're able to say that our MYR is going to be equal to 2,400 inch-pounds. And that's a clockwise reaction. Something I didn't do up above that I should have done, that I generally will do, is I'll do the sum of the forces in the x direction equals 0, right? And because that's associated with this FBD, just to get it out of the way. And here we say that we have a reaction Rx, negative 350, and then positive 150. and we get an Rx is equal to 200 pounds right there. And then I also should have said the sum of the forces in the y direction equals 0. And then that would have been Ry minus 200. Nothing else there, so Ry was also 200 pounds coming up this way. And so like that's just for completeness. I mean, it's kind of obvious because of the nature of the thing, but we still want to write that out, and it needs to be associated with that FBD. For this FBD, we could go ahead and take care of the sum of the forces in the z direction as well. And z is positive right here, and we just say z, and then we can notice rz is equal to 0, right? Kind of just technicalities. Taking care of it though. So now what we know. All right, and now we have one more we have to do. So we took the xy, and we took a look at the xz. Now we need the yz, right? So now we need to have creepy eye looking at it from this direction. Right, and we're going to look at the YZ plane from that direction, coming that way, coming that a ways. So what we're going to see is this thing going to go up, and then it's going to go to the left, right? So writing the FBD, and good practice, right? That right there. Here's Y, here's Z, and so we come upwards, and then we go over. Right? So that's upwards, out of the page, and then over, right? So it's kind of like upwards, it comes towards us, and then it goes out, right? So this right here, sometimes it's kind of like, show it like that right there, right? Because we're seeing that elbow is kind of passing through here. And also we might want to just make a little nod to the fact that that thing is going in the back, but it's not going to do anything, right? It's the forces going that way into the page. So the loads on here are just going to really just be that 200 coming down. It's the only one that you can see because 150 is coming at us, 350 is going away, so we only see this. And this is 16 inches, 16 inches. From here to here. Vertically right here, we don't really care. We could label it though that this is 28 inches, but it's not going to matter. And so for the reactions that we place on here, Ry, which we've already found up above in there, so we don't need to do it, but we do want to label this fully. And we remember that there is no RZ on here. It's going to be 0, but we could put it there as a placeholder. And now for the moment, this one creates a counterclockwise moment, so this one's got to be a clockwise reaction moment. So I will draw it this way, and I'll try to cut the arrow over to a place that's convenient. And this is going to be mx, and we'll say that it's a reaction. So we'd say the sum of the moments about the x direction equal to 0, and we'll just say that it's going to be 200 times the moment arm of 16, and nothing else going on there, just mx is a reaction. So we get mx is a reaction is equal to 3,200 inch-pounds, and clockwise is the reaction that's on there. And that's the big idea, right? So free body diagrams, 3 different directions. There's 3 different moments that are taking place on here. One of them tends to bend about the x-axis. So the one about the x-axis down here tends to try to bend it that way, so the reaction's the opposite direction. One of them tries to bend it around the z-axis. That's this guy right here. And so this is the reaction to that attempt to bend it. And then one of them tries to twist it, right? So a lot of times this will be called torque, because it's the twisting around. You're twisting around a long axis, so you're torquing something in that twist. So you'll see in mechanics of materials, that's where you have a certain kind of torsional stress, right? So there's bending stress and torsional stress. Those are ideas that you'll be covering soon. So here you go. There's another one in the books. And we're 15 minutes done.